batch of 2025, and I'd like to mention that it's my privilege that I start the presentation today very early, and this is the first presentation of our batch for the masters. And my topic is synchronization and control of settings and single and three-phase PV systems. My supervisor name is Professor Anthony Grifo. I'd like to thank him that I underwent surgery 10 days ago. I'm still recovering, but he gave me hope and to stand here. That's why I'm here. My voice may not clear. Are you listening me? I hope my voice is okay. Now let's get back to the synchronization and control. My total system is divided in two parts mainly. One is synchronization and control and PV systems. As we know that, including UK, the whole world is going to step into the decarbonization. The world is getting warmer due to the carbon footprint day by day, and UK is targeted for 2050 net zero. This is why we need to use renewable sources to our daily life. And as an engineer, we have something to do, and our main part is the work with this synchronization process. As you know, with the control panel, and the input power can be connected to the grid with some power electronic system. And in the right side, we can see easily that there is a wind turbine, solar panel, and the greenery and the grid. And we know the grid has different conditions, and the solar inverter output is a different type of phase, frequency, and magnitude. So we need to stabilize it, otherwise there will be a problem of islanding and overall blackout. So there are several types of synchronization method, and before that I would like to mention why synchronization is required. Mainly for the stable power transfer, grid safety, power quality improvement, protection against islanding, and efficient energy utilization. As I said, if we do loss, then it should be our total loss of combined effort. This is why we need to do a better synchronization control process. And this is a small figure that has been showing that the countries which have no idea of putting access to the electricity, they can use microgrid. A microgrid is a grid which can be connected with the some of the homes with their own generating unit, and there we require a inverter. Why inverter required? Because solar panel give very not AC voltage, it gives the DC voltage. So we need to transfer it to the AC voltages and currents, and we can use it to our own systems, as well as it can be used to the grid. We can sell the energy to the grid as well. So those who are not earning much, they can use it for selling their energy to other countries and earn money. I mean other homes. So in case of literature report, I went through several researches, and the research is going on that topic. And in case of synchronization, there are two main topics for open loop method, and another is a closed loop method. In case of open loop method, they mainly estimate the phase and frequency directly. But in case of closed loop method, there is a PLL loop that is called phase locked loop. It is feedback control, and always the angle is being corrected every time after every loop, and because the phase is adjusting through a feedback loop. And there are several synchronization methods. Some methods have one side of benefits and another side of demerits. Like if I say the zero crossing detection, it is easy, but the efficiency is not that much good. And there is a discrete Fourier transform, adaptive notch filter, Kalman filter, and lots of that's artificial neural network, phase lock. All the systems except the last one can be used for single phase and three phase. But the last one, frequency locking, can be only used for single phase. My concern is to work on the PLL. So I work with the phase lock loop only. And as I already mentioned, there are some comparison between which type of filters and PLL loops are giving better, which are not. As we said that synchronous reference frame PLL has a high accuracy, and SOGI PLL, which has been can be used for single phase, and this is the bit comparison. And the robustness to the noise is medium. In case of zero crossing detection, the phase accuracy is low, cost is low, but the accuracy is low. But that's why I think the PLL is the best choice, because it's simple implementation and robustness under different grid condition. It can work for under control grid as well. The PLL is designed to extract phase angle, frequency, and amplitude of the grid voltage, because due to the distortion for noise or some other reason, if the angle is distorted, then it can be corrected due to the closed loop. You can see the block diagram, the down part, the phase detector, loop filter, and the phase angle, and I will show you more later. It always a feedback. So as I said, PLL has mainly three parts. One is phase detector, that is the phase detector means the difference of angles. How what is the angle difference between two signals, like phase 1, phase 2, something like that. And there is a loop filter, that is mainly PI controller, and is voltage control oscillator. SOGI PLL is a second order generation integrator phase lock loop, mainly used for single phase system, and synchronous reference frame mainly used for three phase reference frame. And this is the flow chart. I already mentioned it previous slides. And this is the common SOGI PLL diagram. I took it from a researcher page articles. It was not done by me. It was taken from a book mainly to concept the, and this is our well-known transformation of G and Q transformation from ABC phase, as we already studied it in our two of modules, power electronics modules as well as advanced power electronics modules. The power transformation, this is called power transformation as well. And then the DQ, D is for the active power, and Q is for reactive power. And this is the synchronous reference frame PLL. And as we said, the difference between the grid angle and the DQ PLL is always being corrected, and we are getting the different voltage and Q frame voltage. This is called the reference frame voltages. And I'd like to show you some simulation, and that is the basic concept of this project. And this is the PLL of synchronous reference frame, where I used, I think it's not that much clear. I think that one is clear much better. So it's ABC to DQ transformation. Then it's, as I mentioned here, is the G and Q voltage. Then G and Q voltage is being feedback controlled, and I check the active power and reactive power. And if I check it the oscilloscope, and this is the 120-degree phase shift of my input voltages. Then this is the oscillator output, and it's clearly showing that the oscillator is working. And this is the alpha ABC to alpha beta transformation with 120-degree phase shift. And as I said there in the first picture, you said that there is a 3 signal for 120 degree, and it's 2 signals, so we can analyze it better. And this is the active power. And I made another simulation for single stage, single phase PIP synchronization with MATLAB simulate model. And there I use the MPPT, maximum power transfer tracking, because you know the solar panel, it changes the radiation time to time. So at first I simulate it with the constant radiation. Then I use another
less than 1 minute.
Yes, sir. With the radiation level change. Then there is a driver, and I get it the values. And this is the voltage and this is the grid current after the inverter, and it's almost in phase. And this is the radiation level changing by the time, and due to the radiation level changing, the grid current also changes. And that's my finding. If I make it zoom, then I get that type of waveform. And this is the Gantt chart that I mentioned. And as I was sick, I applied for the extension, and I'm grateful to the university. They accepted for 1 month extension. I'll still work for some update of this project as well. And in the conclusion, I'd like to say synchronization control is very critical for PV integration, and PLL plays a very key role to ensure the stability. And design and performance directly impact grid set converter. And finally, I'd like to thank for your patience hearing. And if you have any questions, please, I'm open to that. Thank you. And yeah.
Thank you.